Okay, let's go over this problem from the practice EOC test. So the problem gave you this part right here, and it asked you what the minimum number of views you would need to fully detail this part. So this is a fairly simplistic object, so you should have thought that this maybe needed not the full 3 views, and that initial guess would have been correct. So let's think about what this would look like from our 3 views. So actually, one of the prior problems on the practice EOC test asked you what the front view of this object would be. So thinking about that, you should have gotten your front view would have looked like this view right here. So this outside cylinder you see in this part would have been represented in 2 dimensions as a rectangle. The inner hole, also a cylinder, would have been represented as a rectangle, but with hidden lines because you couldn't directly see it from the front view. And then this cut at the bottom, the rectangular prism, would have been represented as a rectangle in 2 dimensions. Now thinking about looking at this directly from the top, we would see 2 circles, one this outer ring and one this inner ring here, and we would see the square cut on the bottom with hidden lines. Now thinking about what this would look like looking at it from the side, well, it would actually look exactly as it looks from the front. We'd still have this outer cylinder represented by a rectangle. We'd still have the inner hole represented by a rectangle, and we'd still have this rectangular prism represented through a rectangle on the bottom. The only difference is where our front view is showing us the overall width of the object and the overall height. This side view is showing us those same heights and depths of the object. However, we can get the heights of the object from that front view. We can get the depths of the object from this top view. There are no features, special features on this side view that are particular to the side view that aren't seen either in the front view or the top view. So we actually don't need this view at all. So the minimum number of views we need is 2. Let's look at 2 other examples. So this is a fairly simplistic object as well, just like the object we were just looking at. So our gut reaction should be this probably doesn't need those full 3 views, and that would be correct. Let's look at this side view first. So this side view we know is showing us this overall height, but that's shown to us on our front view. This side view is showing us the individual heights of these smaller parts, but that's also shown to us on our front view. This side view is showing us our depth, our overall depth, but that's also being shown to us on our top view. So we don't need this side view. This side view isn't telling us anything that can't be obtained from either our front view or our top view. So the minimum number of views for this object is 2. We could have looked at our front view in a similar way, and we could have said, okay, well, this front view is showing us our overall width, but so is the front view. This top view is showing the widths of these individual parts, but so is our front view. This top view is showing me the overall depth, but so is my side view. So I could have alternatively said that I didn't need the top view, and I could have gotten everything I needed to know from this about this object from the front view and the side view. So I could have used my front view and my top view. I could have used my front view and my side view, but either way, I only needed 2 views to fully describe this object. Now that's unlike this object here. This object, you can tell right off the bat, is a lot more complicated than the prior 2 we were just talking about. So that should tip you off to the fact that you might need all 3 views for this thing. So this multi-view drawing is set up a little bit differently than some of the other ones we saw, just because if you're looking at this isometric here, this front view is actually the back of this isometric that we're not actually seeing. And what we're seeing here directly head on, which is normally where our front view is actually the side view. So this front view is coming from the back of this isometric drawing, and this side view is coming from the front of it. But let's look at our side views and our top view. So our side view here shows head on this hole. And one of our dimensioning guidelines is that you want to dimension a hole or a circle from the direct view of that circle. So we wouldn't want to dimension the diameter of that circle here, for instance, because we want to dimension head on where that hole is being shown, where that circle is being shown. So really this circle is the only view, this side view is the only view where we can accurately and like fully see this circle. So that's telling us we definitely want to keep this side view. Similarly, we see a feature here on our top view that we can really only see from the top view. We can really only get the details of it. We can really only see the head-on radius of this arc from this view. So we want to keep our top view as well. So this would be an example of an object where we would want to keep all three views. So the minimum number of views needed to fully detail this part would be 3. And that's because there is a feature in my side view and a feature in my top view that I can really only see from that view.